Recording. Great. Before we start further, do you have any questions for me? Yes, go ahead, Giridhar. Right. So Giridhar has some question. In yesterday's class, we separated the line into columns using a simple technique. Yes. Let me also start recording. And this is 17 January. All right. Okay. So ideally, in the industry, when you are doing some real life work, the way we were doing line dot split, okay, will not be sufficient. Okay, reason being, what if the tab is inside a record? Okay, so we will cover that as part of our loading exercise which is coming up, so do not worry about that. So we will, there's a session, the next session is called loading the data. Okay, we will cover it. In case it's not covered, do let me know. Okay, I'll try my best to cover it. All right. So his question, let me complete the question. uh, Let me complete the question so that everybody is also aware. I think this is too big a font. Okay, so the question from Gridhar was very good. Question is, in yesterday's class, we separated a line into column using a simple technique of splitting by tab, right? Now, if the line is, if the columns is, if the text file is in a fixed file format, how do you go ahead with it? Okay, one is that you could simply, if I had to do, let's say this is the line, okay, in Java, you could simply say 0 to 10. So take the characters from this position to this position, and then you can do write strip. Okay, you could do write strip, and that's the column. Okay, so all right, so that's a way you can do it. All right, now this is a very what you call, something which you can do spontaneously, but to be very sure that it is working fine, what you can do is, we will talk about something called fixed file format. Okay, all right, great. So yesterday we left our discussion before starting the combine by key. Okay, or where is the result? All right, there is another function, let me just check. All right, here is combine by key example. Okay, so let me first try to see what happens in case we are translating the data from one to another. I had done a good job somewhere. Okay, yeah. I wanted to show it in this diagram. Imagine that the actual value is in the blue color and you want to convert them into yellow, or is this a green or yellow? Okay, is this a green? I think it's yellow. Okay, so let's say your data or your keys are of one data type and you want to convert them into another, right? Now, earlier what we did was we generally did reduce by key or reduce uh, earlier, right? In the similar fashion, what if, so when we did reduce, our input data type and output data type were both same. Okay, here the input data type and output data type could be different. For example, you have a list of values. Let's say for all list of values, say we have key is Sandeep, okay, and value is value is say 1, okay. Okay, now value is say 12. Now what are we trying to do is we want to group this data by key and we want to concatenate the values, right? We want to concatenate the values in the sense that what we want to do is the result of it should be Sandeep is the uh, key, and value has to be concatenated something like 1 1 2. Okay, or let me give you another example. Let's say the key is Gridhar, okay, and the value is say 10, and okay, and then key is say Gridhar again and value is 12. So what are we looking at in future is Gridhar and 10 12. Okay, so this is what we want to do, and this is a string. Okay, this is a string. Let me put double quote string. We want to do this. All right, now we cannot do it using reduce by key because reduce by key returns the same data type as it takes in the argument. You remember that function, it is the same function definition applied over and over, right? So in these case of scenarios, okay, in so you can think of this value as integer. This is a value as integer and the output we are looking at a string, although we are reducing by concatenating. Okay, so so there are multiple situations involved. Okay, there are multiple kind of functions that will be required for reducing that array of integers into this string. Okay, now let me take the example. Let's say these are the array of integers. This is one integer, the blue one, blue one, blue one, and end result is the concatenation. And these are all the values for the same key. Okay, so as you can notice here is one function required to convert the blue rectangle into the yellow rectangle. Okay, the another function is also required to the another function is required to convert the combine blue and green. You can see this function is taking two inputs here, one from one blue and other is sorry, one blue and other is yellow. Okay, you can see this one. So this is another kind of function, and third kind of function is which is combining two yellows and giving out a single yellow. Do I make sense to you? So the general reduce or reduce by key, the main problem they suffer with is that they can do the operation only in the case where the output and input has the same data type or it's symmetric. So in these cases where it's not symmetric, as in the input is not same data type as the output, then you need to have three functions. One which can convert blue into yellow, second which can combine blue with yellow, okay, and third which can combine two yellows. Do I make sense to you, everyone? How Sachin, Sekhar, Shrish, Valentin, and Gridhar? All right. Therefore, you require three functions. Now, putting it in the same perspective, here we are trying to concatenate numbers into comma separated strings. Okay. So, first function will convert one into a string. Second function will combine one with two, which is another string. And then third function will take third function will basically take 3 and 1 comma 2 and give out this. Okay, let's look at it in a correct perspective. Okay, let's take it into a correct perspective. You can see here, let's take this example is not doing the justice, so I'll have to take a better example. Okay, let's write another example for ourselves to predict, to depict exactly this scenario. All right, so let's dig in. Okay, so we are saying that there are three keys for the same value. Okay, there are three keys for the same, there are three values for the same key. Okay, all right. There could be another key, of course, like this. Okay, or yep. So this is the input data. We are parallelizing it. And then once it's parallelized, we are going to write three functions. Okay, one one that return that convert this one into a string. Okay, we can say fx and it returns. Then we have to define another function, let's say g, which takes an integer and a string, right, that would return x plus a string of y. Okay, and then there will be, or let's just put, yeah, then there will be define h, and there'll be h x comma y. Okay, it'll just return x plus y. Okay, so this is the function that we are looking at. These are the three functions, one from end to end. So we are saying here combine by key. Okay, we are saying combine by key, and this is our new RDD. Let me just give it a name. Let's say counts or RDD and merged RDD. Okay, now this is a create combiner. Okay, meaning F, which is going to create the result. All right, create combiner turns V into C, and merge value is it merges V into C. Okay, it merges V into C. V into C. So it will be, I think, the first argument is going to be this. Let's see if it throws error, we will switch the spaces. Okay, we will switch the spaces. So it is going to be G. Then merge combiner as in the end result, and this is what it is. Ideally, we should be putting we should be putting here a comma. Okay, and again here a comma, and so on. Good. Now let's start with it. Okay, so first of all, let me just log in into our CloudX lab. You have to do a minor selection. Okay, let me go into Web Console. Oh, all right. Now we have PySpark. All right, it's running fine now. Okay, let's just create an RDD. We said, we forgot to put double quote around the B. Okay, so here we go. All right, now let's define a function called f. Okay, all right. Now we have, so combine by key, we have to call combine by key on our RDD, right? We have to say RDD1 dot combine by key. Now you see merged RDD dot collect. All right. Now it starts the process. Now you can see that it has done a good job. Okay. Sounds good to you? All right. Let me take a very good question which Shekhar has raised. Okay. Let me try to answer it. All right. Now question is, in the function f, we have specified how to convert f into C using a string. So by the time G is called, okay, every element must be in C. Good, very good question, Sekhar. That's why this diagram. So it doesn't happen in the linear way. It doesn't happen in the linear way. Okay. So the way it happens is, let's have a look at this diagram. Okay. You can see here that either we have to call string A on all the values in the full partition, or we can do other than this. We can create this kind of environment where we we basically uh, all right, we start getting the results. Otherwise, if you think about it, what would happen? First convert 1 into 1, 2 into 2, and then one more step would be there, isn't it? 1 into 1 and 2 into 2 is something which we have to do it again and again. So there'll be additional function call. That is why, to avoid one level of function calls, we are doing this. Okay, so we have actually reduced function calls by half. Okay, if you want me to draw, I can actually draw, but see, imagine that 1 to be converted into 1, then 2 to be converted into 2, and then 3 to be converted into 3, and then 1 and 2 being combined. So It's extra calls which we are talking about here. All right? Everybody on the same page as me? Brilliant, brilliant. Very smart question. All right. So, all right, I had, that shows that it's very clear to you, Shekhar. And now moving ahead. Any other questions at this point? Okay. The question here is, we are working with RDD. Yes. Thank you, Valentin. Actually, I forgot to mention here. Here, it should be RDD1. And that's what the error we faced here in the, let me take out this terminal out in here. If you see here, that's what the mistake I did, and which I corrected quickly by putting RDD here. All right? Great, great. All right. RDD1 in the merged line. Yes. All right. Is it clear to you now, Valentin? No? All right. Great. Great set of questions. So, yes. Any other questions? I know. Okay. So, these paradigm, what we are talking just now, is actually the basics of distributed computing. This is the baseline, because here what is being done is the work is being distributed. The work of combining values or churning values is being distributed, and we are trying to optimize it. Okay, by reducing number of calls and by making it distributed. Okay, so when you think about getting your work done, you always think in terms of how can I divide my work and get it done over the cluster. And that's a very, very important phenomenon. Okay, one way is that we start using whatever somebody is writing a library. Other way is to actually understand how that library is functioning. Okay, next is what will be the result of this one. Anybody? Okay, so we have a function cc which takes v and returns a tuple surrounded by square bracket. So it returns a tuple containing three values. First value is square bracket starting. Second value is the whatever value we are providing, and third value is the square brackets. Okay, and then there is another function called mv. What it does is, it whatever c and v are given to it, it removes the last character from it. Sorry, it removes the first character of it. No, it removes the last character of this C, and then it combines with V and this. So it creates a tuple. It adds V and square bracket closed into C after removing the last character from it, last element from it. Okay. Now there is something called MC, which takes C1 and C2. Okay, it removes the last character from C1, and it removes the first element from C2. It removes first last element from the C1, and it removes first element of C1 C2 and then joins them. Okay, so what do you think will be the result of saying MC MV and CC. So first execute CC on 1, execute CC on 1, and okay, and then do 2, and then execute MV on the result of CC1 and 2, and then execute MC on the result of MV and CC. So what will be the result, do you think? Anybody? You're free to try it out. Should I copy paste this code? Yes. Okay. So the result is going to be something like this. Okay. Result is going to be a tuple. First character is going to be the square bracket. Second element of this tuple is going to be 1, then 2, then 3, and the last one is a square bracket. Yes, brilliant. So this is the result we are going to get. Good? In the same way, what will be the result of the following? When we say RDD dot combine by key CC, MV, and MC, what will be the result of this one? So let me just try to up to this point, not this point, this point. Let me try to execute. So I created all these functions. Now we have RDD, and we are going to say, let me just say, okay. All right. What will be the result of this? Anybody? Do you want me to copy paste? Gridhar, are you getting whatever I'm copy pasting on the questions window? No? Good, great. So I don't have to copy paste it twice. All right, brilliant. Now, what will be the result of this one? Anybody? All right. Okay, so Sekhar says it will be B, this, and good. Good. Very good, Sekhar. All right. Yes. Let's see. You can see he's right. So the result is going to be this. All right. So either way, the order is something immaterial here between these two elements. Okay. All right. Is everybody clear about it? How did we get this result? Okay. Okay. The question from Gridha is, why are you getting single quotes in the output? It doesn't matter because in Python, single quote and double quotes have the same behavior. You can represent a string inside a single quote or inside a double quote. Okay, just that Python, while printing, it shows in single quotes. Is that your question, Gridha? All right. House question is, in the previous exercise example, we defined gxy. Why we return string x plus comma y instead of x plus comma string y? Brilliant question. I was waiting for this one as well. Here, if you go into the definition here, it says that merge value merges v into c, merges v into c. V is the first argument and c is the second argument. Okay, therefore we are saying, okay, just a second. Yeah, therefore we are saying that basically the first argument is v and second argument is c. Okay, that's the reason. So first argument is going to be the blue box and second argument is going to be the yellow box. Make sense to you? No? This example I think is wrong. Okay, we will have to revisit this. Okay. Okay. So what will happen is that let's think about it. So f basically converts. Now if we are trying to do here, we are trying to do a plus string b. Actually this is not a right representation. This is the correct one. So let me actually update it and so that there is no more confusion. Okay, let me go back here and try to create this. Wow, it's totally made it haywire. Alright, let me see if I can fit in. Okay. Alright. Now what would happen is, let's say we switch their places. Okay, we switch the places and we say string x comma y. we will get a wrong, you know. I will try to do some interesting thing here. Let me uh, help. Let me try to do the little more work here. Okay, so when we say string x y, okay, now imagine this: x is 2, okay, and y is 1. Now what would happen is we will say this plus 2. Now when we try to do this kind of thing in Python, it gives an error. It gives us an error. You can see that we are trying to concatenate a string with integer. All right, does it make sense to you? How? All right, that is why we have tried to, okay, do that. I mean, what you meant to say is, what if we do string y and x? This is what he meant to say. And so it merges the numeric value into the string. So what would happen is x is what? 2, and y is what? This. And therefore it will throw an exception. Alright, that's why I have done that. You must try it out. That will give you the answer. Okay, you can try simply this same example what we have given here and try to switch it. You will get the answer very quickly. Okay, all right, any other question at this point? I hope everything is crystal clear. Feel free to stop me and ask more questions at any point of time. All right, we have done through this. Now again the same thing, sort by key. Okay, sort by key. Also, there is one thing which we have been is ignoring so far is number of partitions. What does this function do? Okay, number of partitions. Okay, what does it mean is after combining and ordering things, how many partitions do you want? Do you want one partition, two partition, or many partitions in the resultant of this one? Okay, if you say none, that means let the system decide how many partitions it can make instead of us saying anything. Or we just ignore that argument completely. Alright? Now moving ahead, similar to sort by, you have sort by key, okay? Sort by key as well. Sort by key does not need a function per se, okay? Sort by key does not need a function here because by default it sorts the data by the key. It sorts the data by the key. At most, you can provide afterwards that, hey, I'm looking for sorting my data by ascending equals to false. By default, the behavior is ascending equals to false. And okay, so this is my tmp1 dot tmp1 dot, let's say, collect. Okay, So it has sorted the data by key. So 1, 2, A, B, D. Okay, you can see A, B, 1, D, 2 has been sorted correctly. Okay. All right. Similarly, you can define other arguments. How many partitions do you want? And the key function. Okay. Key function is again same as earlier. Sometimes you may not want the data to be sorted only by the key. You can provide a proper key function the way we had defined earlier, and we will get the result. All right. Okay. So Shrisi's question is, how is it picking up the key? Is it always the first argument in the tuple or the list, or is there any way to set the key? By default, the behavior is first element of tuple. Okay, this is the by default. This is the default. Okay, and you can define couple of things. One, you can define the element's first element as another tuple. The key itself can be a tuple. Okay, let's say this is your RDD inside the square brackets, and we are defining a key here by saying x comma 1. So then the data will be sorted based on this tuple. The key itself is another tuple. That is another way to control it. The another way of controlling it is by defining a key function. Key function gives out key function gives out the list of keys on the basis of which the data will be sorted. Make sense to all of you? All right. She was able to answer your question. Good. All right. Moving ahead. All right. This is something good that I'm able to copy your data, your questions here, so that everybody can read it, and it's recorded in the video as well. Okay. Now, so that was it. Okay. So everybody is good with it. You can see that I've defined a lambda function quickly here. Okay. All right. House question is, key function is called before sorting? Yes. All right. Next in the same way key value RDD functions. One is subtract by key. Okay. Sometimes you want to remove all the keys or all the value keys from a particular RDD. Okay, in this cases you can simply say x dot subtract by key and collect. That means all the records from x which are present in y, all the keys will be removed from x which are present in y. Okay, so you can see that A1, B4, B5, A2, A3 and C none. Okay, so A will be removed, C will be removed, we'll be left with only B. Okay, now next is join. Join number of partitions with something else. Okay, so returns an RDD containing all pairs of element with matching keys in itself and other. Each pair of element will be joined as kv1 v2. Okay, where kv1 is in the first and kv2 is in the other. Okay, so let's say x is equals to this. Okay, we are joining it with y. Okay, so what would happen is these two values you see here, these two values will come together, and these three values basically, okay, sorry, these two values and these two values will come together. Okay, so I'll show you. So we have this, we have this, okay, and A12, A13. Okay, you can see that A12, A13. So join is basically by default join by key. That was Srishi's question. Good. If there are multiple pairs with the same key and value, will it get retained after join or duplicates will be removed? No, it'll be retained. It'll be considered, the joining will happen twice. You can see 1 and 2 got joined, 1 and 3 got joined. Okay, but generally you should avoid such circumstances because the results might be unpredictable. Okay, because the joins and others make sense only if you have distinct keys. All right, similar to our SQL, you have left outer join as well here. For each element in key value in self, the resulting RDD will contain all the pairs of W in other or the pair if no. So basically, this kind of example will be a better idea. So we are trying to join this with this. Okay. So in case of A, we are saying left outer join. So all the values from the left hand side, what is left hand side? X. All the values from X will go in the output irrespective of whether there is a corresponding key in the right side or not. So all the values from X are going in output, meaning A1 is there, A is there as well as B is there. Now B has got 4 value while there is nothing on the right hand side. Therefore it's putting none. Okay. Now if you had to find out if you had to find out what are the elements in X which are extra from Y, all you had to do is after doing left outer join, you could have said give me all the values. You could have put a filter and checked whichever is none here, meaning those keys are not existing in Y. Okay, so you can emulate subtract by key by using left outer join. Make sense to you? So you can basically left outer join or right outer join are very useful. Although it's not required to have right outer join, because you can simply say the second, I mean, you could simply say y dot left outer join. The results will be equivalent. Okay. So a question to all of you, what will be the result of the following? You have two data sets, one Sandeep, two Shravani, and second data set is one Ryan, three Giri. So if you do a left outer join, okay, this is x and this is y. We are saying x dot left outer join. What will be the output? Anybody? And we are doing the key is the first column. Key is the first column. All right. Good. Thank you, Shekhar. Shekhar says the answer would be one Sandeep Ryan and two Shravani Nan. Good. Great. That is the correct answer. All right. Moving on. Thank you, Shrees. Good. Thank you, How. Very good. All right. And thank you, Gridhar. Okay. I think the second part, it's two Shravani is repeated. Okay. Okay. You are going strictly in the SQL sense. Good. Good. All right. In the similar way, you have right outer join. Okay. No matter what, the right hand side's value are going to be in the output, whether the corresponding ID or corresponding key does not exist on the left hand side. Okay. It's exactly same as the left outer join and right outer join. Okay, so quickly, what will be the output of this one? We are saying right outer join. This is left, this is right. We are saying right outer join. Yeah, yeah. Quickly, the first answer, and I'll move ahead. All right. Sekhar, Sri, Shao, and Gridhar, Valentine. What will be the result of this one? Sachin? That's correct. So how there will be NONE, none as well. If the value is not found on the left hand side with 3 comma Giri, there will be none as well. Okay, good. All right, that's great. Now moving ahead, so it'll be, please pay attention to the order. Sandeep, comma Ryan, okay, and then none, comma Giri. Okay, that's how it's going to be. The order will remain the same as first left one and then right one. Probably it is because of the order you might use this right outer join. Otherwise, you can just switch the left and right and you'll get the results. Okay, great. Thank you, Sachin. Good, Srish, good, Sekhar. All right. Now, just like in pig, you have co-group here as well. You have, let's say you have two data sets. Okay. So for each key in self or the other, return an RDD that contains a tuple with the list of values for the key in self as well as the other. Okay, so it basically joins and groups. It basically joins and groups. So you can see here that, let's say you have A, B, A1, B4, A2, and A3. These are the two data sets. One containing A1 and B4, second containing A2 and B3. Now, okay, so okay, so we could say cogroup equals to x comma x dot cogroup y, or we could also say equivalently y dot cogroup x. All right, so and then you could simply collect. Now the important part is after co-group, the result will be an iterator. So you will have to go and iterate over the list. Only then you will get something out of it. Okay? Only then you will get something out of it. Alright? So the resultant would be something like this. I'll show you something. I'll try to demo you this part because here data types are involved. So it's important to have a look at the result. Okay, so we could say CZ equals x dot cogroup y and CZ1 equals CZ dot collect. Now, if you see CZ1, um, is it CZL? Yeah. So you can see that the resultant is iterable. Okay, so you could simply say here, let's say CGL, and we say 0. Okay, and we say 1, so this is an iterator, so we could say I in this, okay, and print I. Again, the further results are iterable, so we'll have to say for j in I, and we say print j. Okay, let's see what happens. It says 4. Okay, so that is the result we are looking at, this one, the 4. So it becomes list of lists. That is the most important part you need to understand. It becomes iterator of iterators. Okay, so this will look better to you because I've converted the first iterator into a tuple and second iterator into a list by using this kind of tool. So first, these all values will be combined together in an iterable, and then the two iterables will be combined together and forming another iterable where each element is iterable. Okay, that's what is happening here. Okay, so or you could simply say things like this. You could say simply things like this. Okay, you can see B colon A 4, A colon 4, A 1, 2, 3. All right. So that's another thing you could do. Or you could simply do a reduce and convert it into a simple value. Alright, everybody with me? So co-group basically groups the keys first in both data set and then joins that and then brings the values together. Okay, so question to all of you is what will be the result of the following? X equals to parallelize and y equals to parallelize. And then we are saying for, okay, this is little cryptic. Let me make it simple for you. This is little cryptic. What we are saying is this is equivalent to saying for x and y in sorted list. Okay, let me just break it down and make it a little simple for you. This is, let's say, data equals to x comma y, and we are saying data. And let me first break it down so that it becomes sorted list equals to sorted list and data, and we put it. Okay, and this one you can think of it as for xy in SL. Okay, for xy in SL, let's say this is your array, this is your array dot append, array dot append. This is what it is. Okay, okay, please note that we are saying m1 equals to map list y, and then we are saying m1. Wow, this is complex. Okay, okay. So what is it? What is happening here? We are creating tuple out of these things. So this is what is breaking down. So we are saying here, x is this, y is this, okay, and then we have done co-group and converted the data into a list by sorting it. Then we go over SL and then say convert each element of y into an array. Okay, this is what map does. So each element get converted into a list, and then we convert that list into m1. Okay, so what will be the output of the following? Anybody? Yeah, this is what it is. If you see this code, it's a little too cryptic. That's why I have unfolded it and put it like this. Anyone? Okay, this is the data. Okay, this is the actual question. I've converted this part into this. Okay, I'm removing this part. Okay, is that okay? How? Okay, I'll try to paste the actual one instead of this one. I'll just paste this part. Okay, it's going to be a little difficult for me. Bear with me. And here we go. We'll say select here and then cut paste to everyone's. Sri says it will be something of this sort. I've sent you the code. You can try it out if you want to. It's more like an open book. All right. Quickly. Yeah. All right. Let's move on. So the result will be something of this sort. It will be the value for each key will be array or tuple of arrays. Yes. Thank you, Sekhar. That's correct. And you can see that the one array is empty. That shows that the key B was not found in second data set. All right. Next is count by key, which is simple. It counts the number of elements in each key and returns the result to the master as a dictionary. So, for example, we have A1, B1, A1, and A10. It'll give us when we say count by key. Okay, count by key. Ideally, it should be 3 here. Okay, it should be 3, not 2. Okay, you can check it out. It should be 3. Let me also understand if I'm right. Yes, it will be 3, not 2. Okay, although also please note that there's no need of having this sorted to make it easier. Okay, you can simply say something of this sort as well. All right. Good. So this is pretty straightforward. All we did was found the statistics of the keys. Count by key is generally useful for preparing the histogram. Now collect as map returns the key value pairs in the RDD to the master as a dictionary. Okay. So you can basically convert the whole RDD into a hash table. Okay. So you can see here whatever we have here. Because when we say collect, it generally brings us in a array format where each element is a tuple. That's not sometimes desirable because when we are talking about key value pairs collection, it would be better that if we get a map rather than rather than rather than okay rather than a big array having the tuples. That's far more efficient. Okay, so you can see. All right, does it make sense to you? Then next is lookup by key. Okay, so basically after you load the data, you can simply say lookup by key. All right. The better way is you sort the data set and then look up by key. It'll be faster. Okay, so basically lookup returns the list of values in the RDD for a given key. For a given key, it returns all the values in a form of list. This operation is done efficiently if the RDD has a known partitioner by only searching the partition which the key maps to. Okay, so therefore if you sort by key and then look up, it will be really fast. Okay, so while you are looking up, you make sure that you just sort it once and then do the caching. It'll be really fast. After sorting, do the caching and then you look it up and it'll be really fast. Next is the data partitioning. Lay out data to minimize transfer. It's not helpful if you need to scan the dataset only once. Okay. Okay, so lay out the data to minimize the data transfer. It's not helpful if you need to scan the dataset only once. Helpful when dataset is reused multiple number of times in key oriented operation. What does it mean? I'll come back to it again. Okay, so whenever you are trying to reuse your dataset again and again, specifically in the cases where you are iterating over an array or doing some computation, then you might be reusing RDD again and again. Okay, so another basically this data partitioning technique makes the system group the elements based on the key. Spark does not give explicitly control that which worker node has which key. It lets the program control ensure that which set of key will appear together based on some hash value, for example, or you could do a range sort. Okay, I will go back to all of this. All right. Okay. So application scenario is that keeps a large table called user data, which is an RDD of user ID, user subscription topic info, etc. It's a big pairs. Okay, it periodically combines user data with the last 5 minutes events. Okay, say a table of user ID and link info. Okay, for the users who have clicked on a link on a website in those 5 minutes. Okay, so you have a big data set called user data. Okay, and periodically you keep on combining this with the last 5 minutes information, which means you will have to look up the user data based on the user ID and then update link info there. Okay, now what if the objective is to count how many users visited a link that was not one of the subscribed topics? Okay, so every 5 minutes you have this table which has user ID and the link on which they have clicked. All you want to do is find out which are the links that got clicked were not part of the topic info. Okay, so you have this nice website where people take subscriptions from you and you want to observe that what are the extra things the user is interested in, extra topic user is interested in beyond what they have subscribed for. It's a kind of a small recommendation system you're trying to do. Okay, so You have a big database of users containing user ID and user subscription topic info, meaning what are the topics this person has subscribed for. Okay, and every 5 minutes you get the info that these are the topics user has visited in last 5 minutes. Now you want to start showing the recommendation on the right hand side that hey, you might be interested in these extra topics. All right. So in such scenarios, what you have to do is you will have to keep this user data available and ordered by user ID, or you can say sort by a key called user ID, and so that you could quickly join it with the second table and find it out. Okay. You can see that this is where what is happening. We are saying user data equals to load from HDFS and do the persist. Persist as in keep it in the memory. Alright. Now this function we are defining here called process new logs. It takes the log file name. It it loads those events from the log file. Okay, and then join that events with the user data. All right, now off topic equals to join dot filter and user id. And okay, and we what we are trying to do is we return true only in the case where user info topics contain link info. Okay, actually it will be the reverse of it. It will be not. Okay, it'll be a not here. Not user info dot topics contains link info dot topic. Okay, it will basically return those counts. All right, so number of visits of non-subscribed topic per 5 minutes is these many. Okay, so you can see that what we have done is we have tried to join it, and after we have joined it, we have tried to look it up because here topics may be inside as a substring. Okay, had it been like a one-on-one mapping between events and the topics subscribed and the topics, we could have simply do a join between the user ID and this, and we could have basically done a what do you call left join. Okay, all right, so this way we can basically count how many what are the those topics a user is interested in, but it has not subscribed to it. Okay, any questions at this point regarding this? You want me to go through it again? So this is the little inefficient way of doing it. Okay, this is little inefficient way of doing it. Okay, so you can actually uh, yeah, so while we were working on this, we are saying here persist, right, which means we are caching this data. We could have done it little more efficiently, okay, by converting this sequence file into 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 10 partitions and then persist. All right, let me go back once more. All right, ideally what do you call here, All right, let me take one more step back. All right. Yeah. Okay. So what is it that is going on here? What we are trying to explain to you is that sometimes you want to repartition your data based on the key. It's only available. Data partitioning is not creating partitions. It's basically not like whatever we have been doing, like dividing every RDD into multiple nodes. Not that. Here, we are talking about sorting and dividing the data into ranges, mutually exclusive ranges in case of key value RDD. Why would I need it? It would make our lookup really fast. Okay, if you have split your data, if you have properly ordered the data based on keys, then you do not have to look up for the same key on multiple nodes. Effectively, your work has been made really fast, so that when you're looking for data for a particular key, you don't have to roam around all of the partitions. Okay, again, an RDD is distributed onto multiple nodes, and every section of an RDD is distributed across the cluster. So in key value kind of a partition, key value kind of RDD, you can do intelligent partitioning. Okay, so Spark provides you the ability to do the partitioning based on the key, such that the data ranges do not overlap. So those keys, or those range of keys which are there in the node 1 would not be there in the node 2, and Spark will take care of those details in the RDD information. So every time you look up for something, after you have partitioned, if you look up something, it is going to be extremely fast, because it's going to go directly to the node that is having the data and give you the data instead of roaming around the network. Okay, so that's where this data partitioning in case of key value is coming from. Okay, and here is an example which I'm trying to take to explain to you why would you need such kind of scenario. Here we have taken an example of, you have a very big log file. You've got very big log file, and every 5 minutes you have to do certain lookup in this big file. Okay, even if you have loaded this big file into Spark, it will still be slow when you look up for a key. You join by key or do whatever lookups, it's going to be slow. To make it really fast, to make the lookup really fast, you can just partition the key, partition the key value pair RDD such that the data is organized by keys. It's like creating a primary index. Okay? It's like creating an index on the data. You can see that here, the user data we have sorted after joining, and you can basically see that when the event is coming in, it can directly talk to the joined data, instead of, if you see, every time this event is going first, every time we are joining, there will be a lot of shuffling of the data again and again. Instead of that, you can simply partition this user data such that the keys are well organized. Okay, so that there is no difference, no shuffling happens while joining. Okay, if you partition your data really well, the joining becomes pretty straightforward. Okay, Okay, so every time you partition, you're going to get a new data set, and which, if you join with others, it's going to be really fast because it's anyway sorted. Did I make sense to you, Srish and Sekhar? All right. The You can find out whether RDD has got partitioner or not. Let's take a look if our RDD had any partitioner. This is what was that? Yes. Yeah. Let's say we have an RDD, say RDD. Okay. And we can just simply check if there is a partitioner or not. It is saying no. Okay. And then Uh, so you can define your own partitioner later on. Operations that are benefiting from the partitioner is co-group, group with, group by key, reduce by key, join, left join, right join, and so on. So whenever you do a co-group of one RDD with another, the values from the second one, or the keys from the second one, is going to be looked up in the first one, and so on. So wherever this kind of a lookup is happening, all of those functions are going to get benefited from partitioning. Partitioning is more like reorganizing keys such that we know predictively that which node to go to hunt for a key, instead of just trying to find out on all the nodes. Okay, instead of just trying to sort it and find out on all the nodes. So it's very important to partition again and again whenever partition the data, if the data is being used again and again. All right, you can customize the partitioning scheme using a hash function. You can define your own hash function like we have defined here, and return a number. So based on this hash domain is going to be executed on every key. And then based on this number, the partitioning keys are going to be decided. All right. So that is our partition by function. All right. We will take another example problem of that data partitioning called page rank. Okay. So partitioning is more like creating index on a database table. All right. We will talk about it in a minute. All right. Let's take a break for 10 minutes. Back by 10:14 p.m. IST. Oh, thank you, Shekhar, to let me know. All right. Sorry, I actually told the whole story in mute. Okay. So what I was trying to say is, even if you get this kind of error saying address already in use, okay, that doesn't mean it will fail. It will continue and will start. In my case, it has selected another port for my Spark UI. Okay. So I can simply launch this and see. All right. So the driver is running at localhost at this port. Yes, Shreesh. Whether this link from internet as in, all right, how? Yeah, yeah, it does work from internet. All right, how is it failing or what exactly is happening? You're not able to start because not able to bind is a warning. It just means that somebody else is using, so it starts the server at different port. You can see here. In my case, it has started on 4042. In your case, it should be starting at 4043. All right. So nothing to worry on that front. All right. So up to here, everybody is okay. So everybody is okay with partitioning. Great. All right. All right. Let's take another example of a very complex problem. Okay. The complex problem is the page rank one. What does page rank do? All right. So a brief introduction of PageRank. Let me try to take a brief introduction of PageRank. So when Google was started based on this algorithm called PageRank. What they realized was, what they realized was after researching that a page is important if many people are linking it. Okay, and a page is even more important if many important pages are linking it. So the definition of importance is quite recursive. Okay, so and that definition was given by PageRank. So they gave the PageRank to the whole internet, and based on the PageRank, they started showing the results, and they were very highly successful. Meaning, all the pages who are linked by more number of pages get the higher rank, and pages who are linked by higher rank pages are getting even higher rank. Okay, so implementing this algorithm is actually quite tricky. Okay, and this was done by Google guys using many techniques. One was, later on they improved their techniques by using MapReduce on large scale. Okay, because to store their whole data, they needed SDFS anyway. I mean Google file system anyway. So they implemented the PageRank algorithm using MapReduce. Okay, so this was a massive problem. It's a problem of massive scale because it's a problem of internet scale, as in they had billions of pages stored on the with them. Okay, so is the definition of PageRank clear to everyone? Pages who are linked by other pages have more value, and pages who are linked by other pages of higher value highest uh, have even higher values than the ones with the linked by other pages who does not have much value. Okay, so effectively, when one page is linking another, say you are linking no big data, then the value of no big data goes higher. And in case you are being linked by somebody else, then no big data's value is going to go even higher. All right, so this was the PageRank algorithm. Okay, it's more like voting. When you link me, you are going to vote. Okay, you have given me a vote. If you are linking me, you are giving me a vote, and the votes are based on the individual's page rank. Okay, so the algorithm in strict algorithm terms goes like this. The page rank algorithm aims to assign a measure of importance to each document in a set based on how many documents have links to it. Okay, PageRank is an iterative algorithm that performs many joins, so it's a good use case for RDD partitioning. Okay, because it's an iterative. So A voted for B, voted for C. Because of A voting for B, B's value has gone up. Now, when B is going to vote for C, value is going to go up. So the values of A, B, C are getting updated as we are going through the graph of pages. Okay, so this is iterative in the sense that if you run the cycle multiple times, okay, if you run the cycle multiple times, you are going to get correct values. Okay, so the initialize each page rank to 1. On each iteration, the page P sends its contribution of rank to its neighbors. Whosoever I'm contributing, my rank gets divided by number of pages I'm linking to. And my rank, so the overall contribution gets divided amongst these links. Okay, so let's say there is a my page is linking to A, B, and C. So my rank will get divided by the total number of people who I'm voting for, and accordingly, the value or the contribution is given to the other node. Okay, so you can see that there is a lot of times a page's rank is going to get assigned because my rank is being defined by other people's rank, and when I'm linking somebody, their rank is being defined by us, and the whole thing goes in cycles. All right. So the strategy is to divide the rank of P by number of neighbors and set each neighbor who I have voted for they rank as 0.15 plus 0.85 into the contribution. Okay, into the contribution. So initially, the whole internet would have the rank of 1. And as Google crawled the internet, it kept on updating the rank of all the pages and did the iteration multiple number of times. After around 10 iterations, the pages reached to a reasonable rank. Okay, the last two steps repeat for several iterations during which the algorithm will converge. Okay, meaning there will be, after certain time, the value of various page because of voting will stop changing. Okay, they will reach to their actual rank. In practice, it is typically 10 iterations. Okay, is everybody clear about this page rank algorithm? If not, I can explain again. How Sachin Sekhar Shrish. This is the most important algorithm for the internet. Okay, this changed the way people looked at search. All right. So Sekhar and how? Only Sekhar is saying. Okay. All right. Let me try to explain once more. Ouch. Did I do something wrong? All right. Now let me try to describe it. Okay. Let me pull out the graph. Okay. All right. So keep asking questions, please. All right. Let's say there is a page called A. This is A.com. Okay. This is B.com. All right. And then there is C.com. Okay. A is voting C.com like this, meaning if you look at the A web page, there will be a link to C.com and B.com. Okay. So initially, what is their rank? Initially, their rank is 1.0. Everybody's page rank by default is set to 1.0. Okay. All right. Let's also make it a little more interesting. Okay. Let's call it D.com. Okay. And yeah. And its value is also D.com's value is also 1.0. Okay. Initially. Now we start with A. We start with A. Now, how much is A's value? 1. 1 divided by 2. So it is zero point 0.5 is the contribution. This is the contribution from this A and zero point 0.5 to B.com. Okay. How the value of this one gets divided by zero point 0.5 and zero point 0.5. Now let's look at this. This is the formula which says that the actual value that's going to be is actual value that's going to be here is is decided by this formula. How much is the contribution received by this? It's zero point 0.5, right? And we are saying, okay, so how much is this? Anybody? Let me use my Python. Okay, let me use Python. So it says 0.575. Okay, so it is 0.575. Good. And so it's a set each page's rank to this much. Okay. Now, what will be the rank of this page? Of course, it will be same as this one. Okay. Now, next is both of them are giving its contribution to D.com. So the contribution from their side is 5.75 as such. Similarly, 5.75 as such. So the total contribution received is this and multiplied by 0.575 into 2. Okay, 0.575 into 2. Okay, so here you can see its page rank has actually gone above 1.12. Okay, you can see that. So this way you can clearly see that the value is highest in case of D.com. The value in case of V.com is this, and the value in case of C.com is this. Okay. Now, similarly, in case of A.com, the contribution received is how much? 0.15. A contribution received is 0. Therefore, the rank of A becomes 15. And the moment the rank of A becomes 15, again the whole cycle of it will be recomputed. And this recomputation will keep on happening more than 10 times. Correct? Did it make sense to you now? This computation? How? Everyone? I hope I have not confused you all. So this was old value. It got overwritten by 5.75. How about C.com linked to A.com? No, A.com is voting to C.com. Okay, the link from A to C. Now, question from how is, what if C.com was also linking to A.com, meaning there are cycles. Now, even if there are cycles, let C.com's value contribute to A.com and let it keep on going multiple times, and it will settle down to a stable value. Okay. Was that the question you asked? Did I answer the right question? All right. Basically, even if there are cycles like this, say C.com voting for A, okay, still now C.com's value get contributed to A, and this goes in cycles multiple times. The value of A will be neutralized automatically. All right. Okay. So you can see that in this example, what's going to happen is what's going to happen is the values of the links, okay, you can see that in the last two steps several times. Okay, the value of the rank of each page is going to be updated multiple number of times. As we are going through the graph, we are going to keep on updating the page's rank. That means we are going to look up the page's rank multiple number of times. Therefore, it makes sense to do the partitioning of the rank table or rank dataset. Okay. Sekhar's question is, initially, once A had made contribution to B and C, after that, A's own rank would be, own rank will again be computed based on the contributions it has received. Okay, that will be 0.15 plus 0.15, 0.85 into contributions. Okay. So Sekhar's question is, A has not received, let's say A has not received any contribution, then A's value will be 0.15 plus 0 into 0.85, which is 0.15. All right? Does it make sense to you? All right? Now moving ahead, let's take a look at the code. What's going on with the algorithm? Okay? This is not a finished algorithm. It's just good enough to give you an idea of the PageRank algorithm. So for example, let's say there are two databases which we are given to us, or one database called links. Links basically contains who is linking to who. All right. So initialize each page rank to 1 as we have told you. So we are saying links.map values to v equals 1. Okay. So what we have to do is, right. Also note that this we are already doing the partition by. Okay. So now we do the rank computation. So we go in 10 iterations. In the first iteration, what are we going to do? We compute the contributions of a link, okay, by saying links dot join ranks, okay. Okay, so we created this empty link. So links basically contains who is linking to who. Okay, links is having this information that who is linking to who. All right, and then accordingly it's adding the values like this. All right, and therefore so go through this one, you will get a clarity of picture as in what's going on. So first of all, computing the contributions. Okay, this is computing the contribution up to like here. Okay, what exactly are we doing? First we are saying links dot join ranks. Okay, and initially the ranks value is 1.0 and links value is something. So here we are just mapping values, meaning based on the key, we are basically converting the values to 1.0. Okay, keys remain same. So links, whatever links had the key, ranks also contain the same keys, just that the value is 1.0 initially. Now we do the computation of the contributions in this way. We are saying contributions equals to links, this links dot join, okay, this links dot join rank. So because both of them have the same key, they'll get joined. Now it'll be a tuple, first tuple containing who it's linking to, second tuple containing tuple, first variable containing the who, the links list, and second tuple containing the rank. Okay, so you can see that that's what we got in the lambda. We got page ID as the key, links as the rank after joining, and then in the links, whatever we have passed here, we are saying links dot map, okay, destination equals to destination comma rank divided by link size. Okay, what exactly are we doing? We are updating the rank by dividing total number of the values of contribution. We are computing based on this. Okay. Now, total contribution made by all the links is here. Now, we can say contributions dot reduce by key, okay, and then join the data. All right. So the same algorithm what we have just described, we are trying to implement the same thing in Spark. Okay. Go through it, try it out. If you get stuck, let me know. We can discuss it again. That's not an issue. So for each of the page is going to give the each of the page is going to contribute to the rank of each other page, and that's what is happening inside a flat map. There is another map. So for each of the page who is voting to somebody, we have to increase the contributions of all the destination pages. That's what is happening here. No, it is not a Python script. It is the It looks like a scalar one. You can basically remove these where. I think this would work. I think if we had tried to create a Python script only. Okay, what is going on? SC equals to. Okay, so this object file was missing. Instead of that, you can say something else. Okay, so we could say remove this where. Okay, okay, so this is what we did. And then we could do all of this is good. Okay, and then we could simply save it as a text file. All right. So first we compute the contributions, basically do a RDD which contains key as the page and then the contributions. Okay, the actual value for the contribution, and then we reduce that value by the key. Meaning for each key, sum up all the contributions by this formula. Okay. First sum it up like using this particular reduce function, and then convert this summation into the actual rank. Okay, so that's about the page rank. Any questions at this point on the page rank? No questions? I think. Okay, Shrees, Sachin, Sekhar, How, Valentin, and Gridhar. Any questions on the page rank algorithm? Sekhar says we have to implement by ourselves. Later, conceptually, it is clear. Good, good. That should be the right way of doing it. Okay, okay. So this is something. Thank you, how to telling me this. Yeah, I'll have to figure out this. There is a links data somewhere. Uh, Let me just say links corpus. Okay, so I'll have to give you some sample data. Okay, you can basically create any arbitrary data for now. Say A links to B, A links to B, C, B, C, D. Okay, and B is linking to C, comma D, and then E is linking to F, comma G, and so on. You can create a very small file, and that should do the good job. Okay, all right. All right, I'll also try to find if I can some small sample data of who is linking to who, and then you can do the job. Okay. Any questions at this point? All right. All right. So let's start with our discussion on loading and saving data. I hope there is no question at this point. If you have any question, just let me know. All right. So so far we either converted in memory data or we just use HDFS. While Spark supports wide variety of datasets. It can access data through input format and output format, the same interfaces that Hadoop used. Okay, it can access data using fixed all the kind of format which Hadoop supports. It can use all of those for loading the data from HDFS, okay, or any other places. Okay, so because the input format which is supported by Hadoop is actually quite powerful and flexible and supported by many people. Therefore, Spark people made sure that they are very well compatible with input formats. Because there are, as of today, for Hadoop, there is an input format available for everything, be it XML, be it JSON or be it fixed file format. So there is an input format available for all kinds of formats. Therefore, Spark people made sure that the Spark works with all kinds of input formats. All right. Okay, so the common data sources from which Spark reads, and we will go through each of these elements one at a time. Okay, the common file formats are something like text for text, JSON file, sequence file, protocol buffers, and we can also configure the compression while loading the data from these text files. Okay. We can also load data from different data set, different file system, not only from different formats but also from different file system, be it your local file system, be it network file system, be it HDFS, be it Amazon S3. So we can load the data from all kinds of file systems. Okay, we could load data from all kinds of sources. We could load the data from the structured data sources such as Spark SQL. It can it's basically efficient API for structured data sources, including JSON and Apache Hive. Okay, so using Spark SQL, you can load the data from SQL databases. Okay, and sometimes you want to load the data from NoSQLs, and that is also supported. There is a built-in as well as third-party libraries available to load the data from key value data stores. And the kind of connectors that are available are for Cassandra, HBase, Elasticsearch, and JDBC databases. All right. Next is the common supported file format: text file, JSON, CSV, sequence file, protocol buffers, and object file. What does text file means? Text file is like plain text file where the one line is separated from another line by slash n character. JSON file, it's a common text-based format, semi-structured. Most libraries require one record per line. Is JSON clear to everybody, or do you want an explanation? Does anybody wants an explanation of JSON? JSON means JavaScript object notation. Okay, so JSON is a highly hierarchical format. Okay, let's say I had to the user is asking me, you are a server, sorry, I am the server, you are asking me, give me the list of customers. I could give you the list of customers in a very simple format like slash Sandeep Giri slash n and say Shrish slash n and how, etc. Right? But the server could give the result in this format. But what if the name itself is containing new line character? In those cases, you'll have to decide on certain scheme. Or let's say we want to give out the age or we want to give out more details. So this kind of format will not be sufficient. And that's where you have to have the full data format supported, such as this name, or we can say first name, first name, colon Sandeep, okay, last name, last name, colon Giri, okay, age equals 80, Okay, it is little too much. All right, and so on. So you can think of the data being defined like in a really neat fashion. Okay, so an object in JSON is in a JSON object. I think I should just take my MongoDB slides from somewhere. All right, this will be a better way of describing. Okay, now this. All right, here we go. Okay, so what exactly is JSON? JSON is JavaScript object notation. It's very widely used and quite powerful and so on. Okay, and even the simple databases have all moved to the complex one now. For example, Amazon Dynamo is now moved to JSON. Okay, so JSON is something very simple, like saying in this format, saying curly brackets, meaning it's a full object. Object means it has got name and value. Okay, key and value. So name Sandeep, marks 50. Okay, or an element could be, first element could be very simple thing like string or or a number. Okay, a string or a number, that's the kind of elements you have. Then there is a complex data such as object or an array. Array could have different values, different data types, but it'll be comma separated value. List of things. Here it's a description of an object. Okay, it's a description of an object. Okay, and then you could nest one into another. For example, you can take a look at this example. Here we are saying there is this complex object from here till here where it contains many key value pairs such as name, score. The value of name is string, value of score is a number, skills is a list of other values, and so on. Okay, so there are various kinds of things that could accommodate inside a JSON. It could be either an object, it could be an array, or it could be multiple things. All right, I hope this is clear to you. Okay, quick question to all. Which are the valid JSON? Anyone? Out of A, B, C, and D? How says B and D? Anybody else? Yes, that's correct. It's B and D. All right. Good. Any other questions related to JSON? Is it clear to everyone? I can close this session, close this slides. Shrees, Sachin, Shekhar, How, Valentin, Gridhar. Is it clear to you? Can I move on with the rest of the discussion, please? Great. Moving on. All right. So that was a quick overview of JSON. That was a quick overview of JSON. And JSON is JavaScript object notation and then CSV file. You could load CSV file and sequence files. CSV file means comma separated values. Okay. Where the one column is separated by another by comma. Sequence file, it's a very common Hadoop format. It's kind of it has a kind of header and then key and the value. Value could be a binary data. And then there is something called protocol buffer. It's a very space efficient multi-language format and it's by Google and I have used it and it seems to be pretty good. There is new file format called RC file that's also very well accepted by Spark. Okay. All right. So the text file which we have already seen is in the form of input equals to sc.text file. What does that do? It basically loads the text file into an RDD such that every line is an element of the RDD. Okay, the element of the RDD is actually the line from the file. That's sc.text file. Second, the other way of loading the text file is by loading the directory. This is a very interesting thing. Okay, so if you have a big directory containing a lot of small text file, you could use Spark to load the whole directory. Okay, and then every file is going to be one element, okay, such that the key of the element is the name of the file and the value is the content. All right, if you have many small text files where you can afford to load each file as a into the memory, and you are okay with keeping the content of the whole file in a single element. Okay, that's about loading the whole directory. You will understand the significance of loading whole directory when we talk about Spark streaming, where you can keep on putting files into a folder and Spark will consider that as if the data is continuously flowing in. Okay, and to save a text file you could simply say result.save as text file. Okay, so after you um, do this, after you map the values such that you convert the string into the length, this is how it's going to look like. All right, should I show you this part? Okay, let's try to see what happens. Okay, or let me go in here and try to see. I like to go into big because that gives me a quick access to the data file system. So ls slash data. Okay, inside data you see this folder. Let's try to load that folder inside PySpark. Okay, so we can load this folder slash data ml100. Okay, now here we go. Also, if you are curious as in what is there inside that folder, you could say this, not this. Hadoop fs slash data slash ml 100k. you can see that there are so many files. Some of them are really huge, okay? Some of them are really huge and some of them are small, okay? You can see some of them are 1.7 MB, 1.5 MB, and so on, okay? So let's try to load this folder into an RDD. How would you load? Okay, you will say sc dot whole text file, and we say slash data slash ml 100k. What was that? Whole text file is whole text files. And let's assign it to our RDT. Okay, so this is our RDT. Alright, now if you just take a look at one of the elements, okay, we just say rdd.first, you'll get a clear picture. You can see that. You can see here. Basically, if you look at it closely, it's a tuple where the first one is this big file name. Okay, so the key is this file name. Now we can do things like just count the length of each file, count the length of each file. So let me just do this. Okay, I'll just say rdd. Okay, and then you can see that for each file we have computed the line number of the length of each text. Okay, you could save the data to this file. Loading the data. So if there are two ways of loading the JSON. Okay, so the loading the data as a text file and then map over the values with the JSON parser is also good. Also, we write JSON file as text file. We can also load JSON in something called Spark SQL. We will discuss that later. We can use per partitioning process as well. Okay, we can use per partition processing too. All right. Let's try to download some. Let's try to do something. Okay, here let's try to download some data. All right, what is it that we are trying to do? Okay, we are trying to load the data from JSON file. So first of all, we'll have to download this particular zip file. Okay, so how do you download from zip file? You say wget and this folder. Okay, so we have downloaded stocks.zip. Okay, now take a look at what's there inside this file. It contains something of this format, although it looks awkward, but yeah. Okay. All right. So let's first load this file as a text file, normal text file. All right. Now, what we do is let's have a look at the input.take. Why is getting into that? Yeah. Input.take 2. Okay. So the important thing you need to understand is not this. Uh, yeah. It has to be something like this. Let me just check if it's working or not. Okay, it's expecting this into HDFS. Okay, let me just put it in HDFS. So I'm saying Hadoop fs copy from local, okay, and stocks.json, Hadoop fs minus ls, okay. So this is my folder. Now I go back in my folder here. Let's say data equals to sc dot text file and slash user slash this, and I say stock dot json, data dot first. Again, I think I have made a mistake, and stock or stocks, it's stocks. Okay, so it's stocks. So I've loaded this data. Now what I wanted to show you is take two. Okay, what I wanted to show you is basically this file which we are talking about here, it contains data such that every row is a JSON object. Although the whole file is not a valid JSON, but each row is a valid JSON. In such cases, it makes more sense to load the whole text file as RDD and then use the JSON parser inside a map so that we can convert each string into JSON object. Okay, that's what we are trying to do here. You can see here we are saying input equals to spark context dot text file. We have loaded this text file. Okay, next thing we are doing is creating a function which, given the text, converts the data into JSON object. Okay, and there is a JSON object provided by Python itself. Okay, I can show you this. I can show you quickly that Python provides you a JSON object. If I go into Python here, I could say import JSON, and then we could say JSON dot loads, and here we could say 123. Okay, you can see the JSON has been loaded. Okay, all right. So it has converted the JSON object into a normal object. That is something I wanted to show you this. Okay, so basically JSON dot loads convert any string into an object, meaning a JSON data, converting a JSON data into an object. Okay, that's the whole purpose of JSON. All right. Now after this, we could just pick up some value from it. Here we are picking just the ticker part of it, and then pass it to another map or whatever. Okay, so the most important line to understand is this particular part, okay, and this part. So we first loaded the data as text file such that each element is a valid JSON. And then we did a map, and each element from string got converted into the valid object. Okay, using this map function, we converted each element into JSON. All right, so you can try it out. Here we are converting back JSON into we are converting back an object into the JSON format by using json.dumps. It's a method provided by Python which can convert any JSON object or any object into JSON format. Okay, so here we are not utilizing any special, we are not utilizing in this example any special loading method provided by Spark. We are just relying on sc.text file, and then we are doing map, and for each of the element we are calling JSON methods to get the job done. Okay, so now I can give you a quick demo here. So this is the function here, and it takes anything. It takes, let's say, it takes what you call ticker and 10, and that's it. So we have to say import JSON and then call the same function. Okay, what does it say? Okay, I think it's expecting a full JSON object. Okay, why? So JSON dot loads. Let's see if it works. All right, it's expecting certain thing. Is there an error in this? All right, never mind. We already have some data, so we can right away experiment on that. Okay, you can see that it has loaded the data, and then what we could do is we could convert it back. How much time is going to take? Okay, and we can say data.save as this, and I could say my output directory. Let me just remove this. Okay, now let's check in Hadoop fs-ls. So you can see there is an output directory. You can see that part 0, part 1. Why? You can see that it has saved the result into the file system. It was pretty straightforward. All we did was we translated each object after filtering and do whatever churning. We translated each object into JSON and then saved that. I think we should have saved this out JSON as a text file. Okay. All right. Now coming to the, so is this JSON format clear to everyone? Great. All right. Not clear? All right. Great. Now let's try to load CSV and tab separated format. Okay. So the clever thing which Spark people did was instead of reinventing the wheel, they made it possible to use the native libraries to do the job because those libraries are very mature when it comes to parsing the data. Okay. Similar is the case with CSV and TSV. Records are often stored one per line. Okay, in CSV as well as tab separated value. In both the cases, the records are separated by /n. Okay, and mostly in CSV as well as TSV, the number of records per line are same. Okay, and the fields are separated by a character such as a tab or a comma. Okay, and sometimes the only way to detect a header is by so the generally the first row is dedicated for the header number, header details such as the name of the column. All right, again loading CSV is very similar to what we have done in case of JSON. Okay, so for each line we are going to call the CSV dot dictionary reader. Okay, why are we doing this way? Why didn't we load using our Python program? Because Python program would run on a single machine and overflow one single machine's memory. Okay, and that's where what we are trying to do is we are loading it as a text file such that each line is an element in an RDD, and then once we get each line as an element in the RDD, for each line we are going to run map function. Okay, and what does this map function do? It's calling load record. It's calling load record here, and this load record interestingly takes a text line and then passing it to the dictionary reader. Okay, and it will read this data from each line and convert the CSV format. Okay, it's a standard way in Python to load the data in this manner. Okay, and then you can do return next. All right, all right, let me try to see if I can find out any. So how do you find out in HDFS? You could say Hadoop fs minus ls minus capital R, and then all of it, it'll basically start traversing the Hadoop, and you could say CSV. All right. Doesn't seem like it has. Is it giving any result? Oh, I'm so sorry. I'm trying to run it on my Mac. It doesn't, it can't connect. Hadoop fs minus ls minus capital R data grep minus I, and we say CSV. Okay, so we have ratings.csv file. Let's try to load this file in. Okay, in here. We say my ratings equals to sc.text file, and we say this. Okay, now let's go ahead and try to define this function. First, do import both of them. Okay, we did both of them, and then we said this part. Okay, there is some formatting issue. Okay, what was the name of the input file? What was the name of the input file? It was called ratings, and that too with a bad spelling. Okay, now let's say input dot first. You can see, all right, we were able to load the data. Okay, so it was pretty straightforward to basically loading the text file and then map using map, parsing each line and converting each line into a CSV object. All right. Sometimes you want to read the whole text file, and then you want to parse the whole text file on one single node. Okay, you can do that using whole text files, and then use this. In case there are many files, many CSV file under one single folder, you can use whole text file. All right, that's how you can load the data in CSV. Again, here also we are using the same library to convert the data into CSV. Okay, CSV data into an object. Similarly, we can use csv.dictWriter to save the CSV data. Okay, you should try both all these examples. So a very strong recommendations to all of you. First, finish all the assignment provided in the no big data here. You must have seen here. Please go through all the 3-4 sections and finish the assignment. Okay, you go through this quiz, similarly this quiz, similarly this quiz, and more subjective assignments are coming your way. So finish these assignments very quickly before next Saturday. You will get a couple of assignments as well. Okay, in the meantime, make sure that you try to execute these text loading examples. Right. All right, Sheesh, you got the idea. All right, try running these CSV examples. That will be a big help for you. All right, also try running the PageRank example. All right. Thank you very much and see you on the next week. Okay. See you on the next weekend. Bye bye. Have a great day. All right. Have a great week ahead. Thank you, Srees. Thank you, Sachin. Thank you, Hao. Thank you, Valentine. And thank you, Breather. Have a great day ahead. Bye bye.